Well, the definition for an ellipse is the set of all points whose distances from two foci sum to a constant. And you don't have to memorize that. But I do want to show you just very briefly what that means. I'll give you a second to write it down. And then that should make sense to how we see the equation. I could show you the equation or how we get it, but we don't have quite that time. Very good. 20 seconds here. Thanks for your help, Les. That was a good. No, that was a very well. We had a very well run meet. Okay, so I have two foci, foci 1 and foci 2, and if I were to draw an ellipse, it just so happens that if you take a point on the ellipse and you look at the distance from one and the distance from another, that those should sum to the exact same number as, say, this distance 3 and this distance 4. What do you think? Do the reds look like they sum to the same as the blues? It's kind of harder to tell than the work we did yesterday, right? Kind of tougher to tell. The way that we would like draw an ellipse, if we were to construct one together as a class real quick, I used to have people do this when we had a little bit more time, but we would take like Emma's shoelace off. We would tie it into a loop. And then I would put my fingers on the foci, and then we would just take a marker, like stretch out that loop. And as that loop would stretch out, instead of heading around one point and swinging to make a circle, it heads around 2 points and makes an ellipse. That's what happens. So you can make an ellipse pretty easily. And if you think from like a rotational perspective, so planets travel in elliptical motion, right? And so sometimes these focal points can be masses of gravitational pull. You know, like the Earth moves around the sun, has other planets and things that have gravitational pull to it. So therefore, you have those elliptical shapes. So the equation looks as follows. We have x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. And if you notice here, we have x and y. We have two sums, so the set of all points whose distances from two foci sum, so they sum to a constant. See that? So ellipses being sum, and they have a constant there. So the center is going to be HK. And then they have what we call vertices. The vertices are the endpoints of where it's stretched the most. So I have a vertice here, and I have a vertice here. I have two vertices. Now, how far do we stretch? Very simple. Look at the number that's under the x. We have an a squared. So we go the square root of that, or we go a units in that direction. And then we go b units, the square root of b squared, we go b units in the y direction. That's how far we go up and down and side to side to kind of make our ellipse. So the vertices are those endpoints, and if it's a units away from the center, okay, is that going to change the x value or the y value of the center? For moving horizontally, it's going to change the x value, so h. So the vertices can be at h plus or minus a, and then k. So the k value doesn't change, but h does. You just add or subtract a to the h. The major axis is the distance across. And so if this is a and that's a, what's that distance? A plus a, which is 2a. And so then the distance the other way for the minor axis would be 2b. And the foci are these points. They are the points that we kind of use as I was talking about how we generate, you know, that ellipse. Foci, they sit c units from the center. So instead of moving a units from the center, we just move c units from the center, okay? And then what we have is we have this eccentricity piece, okay, this eccentricity piece, okay? And eccentricity is the measure of how stretched the ellipse is. For example, does the ellipse look more like a, kind of like a line, or does it look more like a circle, you know? And eccentricity is a value between 0 and 1, and the way we measure eccentricity is we take c and we divide it by a. Take c and divide it by a. The closer the value is to 0, the more the shape looks like a circle. The closer the value is to 1, the more it looks like a line. Okay. All right. So the only thing you need to know up here is how to find c. And there's a great formula for c, and it's a squared and b squared and c squared. Anybody want to guess what goes in the middle? There is an equals, but it's instead of plus, it's minus. And if we're going to subtract two things and then take the square root, we have to have a positive number. So if this needs to be positive, which is going to be bigger, a squared or b squared? So a squared is always bigger than b squared in these scenarios, okay? So what happens if we flip it vertically? Well, the center is still hk. But the equation looks like this: x minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1. So what changed with my formula? What changed with the equation? The a and the b. And what's important is that is a the bigger value or the smaller value? So when the bigger value is underneath the y, it's stretched more in the y direction. And when the bigger value is underneath the x, it's stretched more in the x direction. That's all that means. So the vertices are located now vertically. So we move a units from the center. That's going to change the k values. We have h and we have k plus or minus a. The distance from one side to the other is, again, twice that a value. And then that shorter distance across that minor axis is going to be twice the b value. Foci still sit c units from the center. And so your coordinate is h, and then it's k plus or minus c. So this time the y value changes because it's switched vertically. And the eccentricity is the same. So a lot of information to put down. This can be a good reference. Sometimes this makes sense for people, sometimes it doesn't. I tend to not really look a whole lot at this stuff. I just try to think about the big picture, and especially what A and B are. So we're going to identify the center, the vertices, the length of the major axis, the length of the minor axis, the foci, and the eccentricity. What's the center? 0, 0. There's no minus or plus for the x and y, so we just have 0, 0. How many units do I go in the x direction? It is 2. It's the square root of 4. So I go 2 units in the x direction. How many units do I go on the y direction? 5. So you can see how simple it is to construct this ellipse. I just moved 2 units in the x direction, 5 units in the y direction. And how is your ellipse? Did you do a good job? Is it a little bit sloppy? Yeah? Okay. It's hard to draw a really good ellipse. The vertices are the endpoints where it's stretched the most. What are the coordinates of where it's stretched the most? Yeah, it would be 5, 0 and negative 5, 0. You could just write that instead if you wanted to as plus or minus 5, 0. If you want to write it like that, that's just fine. You okay with that? The length of the major axis is the longest distance, which is 10. The minor axis is this distance, which is 4. In order to find the foci and the eccentricity, what value do I need to find that I don't yet have? C. And the way that we compute C is we do a squared minus b squared is c squared. A squared is 25 minus 4. So this is a squared is 25. We don't have to do anything to it. B squared is 4. We subtract those, we get c squared. So 21 is c squared. Okay. So c is the square root of 21, which is approximately 4.6, right? So as I plot that, I'm going to move along the major axis 4.6 units. And now I'm going to name those foci. They would be located at 0, root of 21, and 0, negative root of 21. How else could you write it? 0 plus or minus root of 21. That's just fine if you write it like that. Okay with that? Then finally, the eccentricity is your c value, which is the root of 21, and you divide it by a. Do you remember what the a value is in this problem? 5. And so if you take the root of 21 and you divide it by 5, yeah, we're doing something weird at the end of class. We're going to divide that by 5. I get 0.92 approximately. So I just want to make sure that that number is between 0 and 1. And it's closer to 1, which means this is a fairly stretched ellipse. It looks like it's kind of really getting stretched. Okay. Not too bad. So each of these problems on the test, I do this one really easy as well. So 6 problems, each worth 8 points. So this one, I'm going to set it equal to, right now it's equal to 36. That's not like the equations I have. All the equations are equal to, so how could I make it equal to 1? Divide by 36. And so when you divide by 36, I get x squared over 9 plus y squared over 4 is equal to 1. As I align my smart board, because things are getting a little bit out of whack, if you could please just sketch a quick graph of that and start to list some of the components. Sorry for the distraction. Okay, I've got the center at 0, 0, and I went 3 units in the x and 2 units in the y. Is there any question how I went 3 units in the x and 2 units in the y? Okay, everybody see why? Okay, so you just, notice how nicely it corresponds with the x and the y, but sometimes people wonder, well, do I always go the x first and the y or whatnot? Just look at the labels and go from there, okay? So the vertices are the endpoints, so you should have positive 3, 0 and negative 3, 0, or plus or minus 3, 0. Hey, buddy. What's the length of that major axis? It is 6 units across. What's that shorter distance? Shorter distance is 4. In order to determine the foci, what's my equation? A squared, which is 9, minus b squared, which is 4, is equal to c squared. So that means c is equal to what? Square root of 5. Square root of 5 is about 2.2. So I move 2.2 units in each direction. 2.2 units in each direction. So the foci will be located at plus or minus the root of 5, 0. And what's my eccentricity? Square root of 5 over, we divide it by what? 3, yep. So if I can help you guys out from just a geometrical or graphical view, it's always that distance divided by that distance, okay? We're taking just that distance divided by that distance. So it's that over that, so it's square root of 5 over 3, not the 9. And when I divide those, I get approximately 0.75. And so it's not as stretched as that one was, okay? It's not as stretched. You okay? All right, one more example. We're not going to do letter B. We're going to choose letter A instead. So how is letter A different from the other ones we've done? Yeah, the center is going to be shifted. What is the center? Yeah, it's shifted to the right 3. So the center is now 3, 0. And then I want to just do some kind of thinking before I make my graph. Notice that the A value is going to be 3 and that the B value is going to be 1. Okay? So what that means is I got to be ready to move 3 units in any direction. Okay? 3 units in any direction. So what's the biggest I would need my graph to be if I can move 3 units in any direction? 6. Everybody agrees 6 would be enough? So I'm going to make a 6 by 6 graph, and that should be enough to see everything I want. 1, 2, 3. All right, I plot my center. You tell me, what will I now do to sketch the graph? Where should I go? From the center, move where? Right 3 and left 3. What else should I do? I should move, because it's y squared over 1, I'll move up 1 and I'll move down 1. Great, let's name those vertices. All right, can everybody appreciate how simple it is to actually construct an ellipse by looking at the equation? Center and then move, right? And now we can name the vertices. I've got one at 0, 0, and the other one's located at 6, 0. The major axis is the distance across. What's that distance across? It is 6. The minor axis is going to be this distance, which is 2. Look at how quickly we produced all that information. In order to find the foci and the eccentricity, I need to find what value? See, I take a squared, which is 9, minus b squared, which is 1, and I get c squared, or 8 is c squared. So what is c then? 2 roots of 2. Thank you for simplifying. Those things come along with us. Somebody during second hour asked, well, what if I don't simplify that to 2 roots of 2? I say, that's a half a point off. You know, gotta continue to do those things. So 2 roots of 2, I happen to be good with the old integers. I know it's about 2.8. So I'm going to move 2.8 units in each direction. Notice how close that is to our vertices. So this thing is really stretched. Really stretched. So we're going to name that. Here's kind of the last thing you got to think critically about. As I move from the center horizontally for those foci, is that going to change the x value of the center, or is that going to change the y value of the center? Changes the x value, doesn't it? The y value stays the same, right? So I know that the y value is 0. All I do is I change the x value. From 3, I added and I subtracted 2 roots of 2. So that would be the customary way of writing the coordinates for those foci. Is that good? Good. So that's 2 of them. We have one is 3 plus 2 roots of 2, and the other one is 3 minus 2 roots of 2. 0 for both y values. The eccentricity is your c value, which is 2 roots of 2, and you divide it by the a value. Who remembers what the a value is? It is 3. And when we divide those, we get 0.95, I think. Let's go 2 roots of 2 and divide it by 3. 0.94. It's about 0.94. And again, we want that value to be between 0 and 1. You can see as it's closer to 1, it's more stretched. That's just kind of a good check to see that we know what we're doing. Not too bad. So the ellipses assignment can actually go pretty quickly. Just know we will have days of instruction both Wednesday and Thursday. I want to get all the material in front of you. Test next week Friday in the midst of all the AP and Big 9 music and all those other things that we're missing. So good job.